present about thin film article on the topic of the effect of titanium concentration on the structure, optical, and theoretical property of aluminum and titanium coated zinc oxide thin films. Our member have Mr. Chachana, Ms. Hanpakon, Ms. Kanchia, and Mr. Jason.
Okay, let me about zinc oxide thin film. Zinc oxide-based compound widely studied because it is transparent conductor or semiconductor material in cinema field. Figure 1 shows structure of zinc oxide is hexagonal with lattice. For application, thin film transistor or TFT, solar cells, light emitting diodes, and flat panel displays. When zinc oxide compared with indium tin oxide or ITO that found high transmittance, high chemical stability, non-toxic, and low cost. This research study about aluminum dope in zinc oxide structure with varies concentration. Concentration of aluminum is suitable at 1 atomic percent. When zinc oxide compared with ACO and ATCO, that found ATCO have lower resistivity. In this study, ATCO grow on gas substrate by sodium method. The influence of titanium concentration on structure, optical, and electrical properties. The optimum concentration of titanium were determined according to the resistivity and transmit value of thin film.
In experimental, we have two parts. The first part is preparation of sample. Then it deposits on glass substrate by dip coating technique. Before the deposition, the substrate was cleaned by acetone, ethanol, and deionization water. Film were synthesized by flow gel method. 2-methoxyethanol used for solvent and diethanol amine used for stabilizer. The first, single state dehydrate was dissolved in the solution. Then add aluminum nitrate monohydrate in the solution. And finally, add titanium tetra-N-butoxide solution by very concentration of titanium. All of sample stir by magnetic stirrer at 70 Celsius degree for 2 hours. The film deposits on glass substrate by dip coating technique. After that, the film was dry in oven at 300 Celsius degree 15 minutes to evaporate the solvent and remove organic residue. The sample were annulled at ambient atmosphere at 550 Celsius degree for 2 hours. Next, we move to characterization part. X-ray diffraction used for investigated structure, crystal structure by copper K alpha radiation from 10 degree to 18 degree with scan speed of 5 degree per minute. Field emission electron microscope used for investigated morphology operate at 25 kilovolt. Atomic force microscope used for investigated roughness and in contact mode with the result precision of 0.1 nanometer. The test spectroscopy used for measure the optical transmittance and band gap with wavelength range of 300 to 900 nanometers at room temperature. Ellipsometer used for measurement thickness and refractive index and extinction coefficient with incident angle of 70 degrees. Spectral wavelength was from 250 to 18 nanometers with depth of 5 nanometers. LCR meter used for measure resistivity.
Pre-session discussion. In Figure 9 show the X-ray diffraction pattern of sample having different titanium concentration. The pattern shows that all samples are good agreement with Joint Committee on Powder Diffraction Standard, card number 891397. All samples are single phase and no evidence of secondary peak from titanium substitution. In Figure 9a, observer of peak in pattern show that the samples are crystallized structure and random orientation. When comparison between them found that peak intensity were decreased by increasing of titanium because zinc is substituted by titanium in zinc oxide structure and restricted the crystal growth, especially in grain binary. And also found that peak shift to higher angle because titanium iron is lower side than zinc iron. Using Scheller formula to calculate the crystal size of sample shown in table 1, found that the crystal size decreased upon titanium increase. As for lattice parameter, the sample are hexagonal wolf side structure using backlog with equation 3 to calculate it. Shown in table 1, lattice parameter A and C decrease upon titanium increase too. The next is result from FESEM technical. In Figure 11, show the surface of sample with different titanium concentration. Found that mean of grain size decreased by increasing of titanium because titanium incorporated in single side structure may tend to create more nucleation center. Next feature is causation of sample with 0.280% titanium concentration. The surface is uniform and compact with columnar structure. The thickness is 220 nanometer, but we will explain further again about that in ellipsometry analysis by Mr. Shashna. Next, the roughness of sample are analysis by AFM technical. In this 3D image, show that the surface is smooth up with titanium concentration increase. In Figure 14, RF roughness will decrease from 8.2 nanometer to 3.4 nanometer upon titanium increase. Due to grain size of sample decrease, which agreement with XRD result.
Now I would like to talk about effect of titanium content on optical properties. Optical transmittance was decreased when increased titanium content shown in Figure 15a, and Table 2 show the calculated average of transmittance value in visible range. This result can make sure that the transmittance depends on microstructures such as grain boundaries. If increased titanium content, grain boundary was increased and may predict scattering effect. And we can use this formula to find absorption coefficient and use transmittance in these formulas. Next, next about electrical properties. We can find optical band gap use Tau models with give absorption coefficient equal 0, shown in table 2. And Figure 15b shows the relationship between energy absorption per unit area and photon energy in absorption regions. This widening, called Browning-Morsheep effect, is result from the filling electron state near the bottom of conduction band and make Fermi level leak into conduction band. Next, about electrometric analysis. Use Cauchy model about refractive index to find darkness. The refractive index was decreased, shown in Figure 16a, and because titanium can act as effective anti-brothers to generate free charge carriers, the increasing of free charge carriers will make the refractive index decrease, and can make sure about reduced roughness. And moreover, the ellipsometric analysis can beautify thickness shown in table 2. And about extinction coefficient, use Cauchy model shown in figure 16b. Extinction coefficient is decreased with high wavelength at the 400 to 800. Therefore, sample is a transparent material. Last about resistivities, shown in table 2. As can be seen, resistivities increase with increased TI content. Maybe in this stress field, which will reflect and reduce mobility of the charge carriers. In similar research, offer 2 probable causes for reduction of conductivities. First reason might be carrier trap at grain boundaries, which could entrap the charge carriers. Second reason could be the light deformation of the interstitial metal atoms and depression of oxygen vacancies as a consequence of titanium incorporation.
Conclusion. Finally, that find all of samples have hexagonal wood-side structure. Grain size, RMF roughness, and refractive index decrease when doping titanium increase. Transparent and transmittance decrease when titanium content increase. The band gap increased from 3.26 to 3.21 electron volt, attributed to Gutenberg effect. And the optimum concentration of titanium is 0.1 atomic percent. Thank you for your attention.